All right, so I'm sorry I'm not here today. We're going to talk over dimensional analysis. We've already spent time talking on this earlier this semester during warm-ups, but I wanted to make sure this really ties into our exponent laws. And I thought y'all get a kick out of the comic that I put up there. I know that's how a lot of you guys feel. This is going to give you another way to look at word problems, especially when we get to chemistry and the different classes you're going to have next couple years. Okay, so what you see actually in front of you right here is dimensional analysis. Okay. All right, our example 1 and 2, we can really see that, we talked about if we think about exponent rules, okay, we learned a lot. If the squares are x's, let me change my color. If the squares are x's, the hearts are y's, and the triangles are z's, if you think about how we set that up, that would be x over x, y over y, z. There's your exponent law. 1 minus 1, they cancel. They cancel, you're left with z. And the same here. It doesn't matter if they're directly on top of each other on the second one. Goodbye, goodbye. Okay, this doesn't have anything to go with, but the circles do. So what I'm left with is moon and octagon. And it works the same over here. You guys think what shape would end up being left over here? It's going to end up being the triangle. And over here, what's going to be left is this shape right here. That's really all dimensional analysis is it applies the quotient law or the quotient rule to units. And the power rule, or the product rule, sorry, the quotient and product rule, okay? And that's all it's really taking and learning how to use that in terms of units, not just x's and y's, but inches and feet and miles and yards and whatever else this stuff comes up with. So if I think about this, before we kind of jump to the next piece, if I had to go, okay, how would I change months to seconds? So if we think back and can think through these, how would I change this? Well, first I've got to get months down here. We talked a lot about this. We're going to cross through any units that cancel. And what we want to do to cross is to put them on the bottom. Okay? So I'm sorry, I need to erase that. We're going to have to go from months. Now, we won't have a direct conversion to days, so we're going to have to go months, and months are going to have to be down here. Just doing months, okay, to days. Days, cancel it out. Days go to hours. Hours cancel here to minutes. Seconds here over minutes. Each time, if you look at it, we get that cross-out method. And all we're left with is seconds. That's the only thing that's left uncrossed. That's the key behind dimensional analysis, is just to work at that. So if we look at a more complicated version, and I have more on this on the next page, you guys can see, this is just a more complicated version. The teachers at Zebra High are known to assign a homework. It's kind of like me. If your students take 6 classes per day, each class has a half hour of homework, how many hours of homework is that student assigned per marking period if the school day is 200 days and each marking period is 1/4 the year? And kind of works through the problem. So you can take a look at it now. If you look down your page, you'll see it's just another way to look at it. These are all the conversion factors I know. 6 classes in one day, half an hour of homework per class, 200 days in our school year, and 4 marking periods per school year. So if we stop and look that around, if our goal is to cross things out, okay, we want to say, okay, so we have 6 classes a day. So we want to find out how many hours of homework is assigned per marking period. So I want marking period to be left over, and I want hours to be left over. Those are the kind of keys I'm looking for. So if I know that we have 6 classes a day, so there's our first setup. Sorry about that horrible line. But I wanted to make classes come up here. So 1 class, half of hours of homework. So now I've got to code my next step. And we talked a little bit about how train tracks work. Okay, I need to get from hours. So I want hours left over. Okay. And then I got rid of classes. I got classes. Oh, I have that in the wrong spot. I don't know what I was thinking. There we go. So 0.5 hours, 1 class. That would cancel, and I get rid of hour. So I've got hours. Hours is where it needs to be. It's the answer to the question. It's hours over here over marking period, MP. Okay, so I need to go get rid of, so I've got that. I need to get rid of days. So there's for 200 days over school years. So the days go away. And now I have 4 marking periods and 1 school year. So you can see all I have left over. So I'm going to do 6 times 0.5 times 200. So I'm really going to get, all right, 6 times 200 is 1,200. Half of that is 600 divided by 4. So they're going to have an average of 150 hours per marking period. All of it is just setting up and making sure those equations cancel, so that if I use the quotient law, it lets me cancel it out. So if I try another problem, you're setting up a party. Let's think of we got 15 people. Each person eats 4 slices. So if we have 15 people, okay, sorry about my poor handwriting. 4 slices per person, PP. We call the pizza place. Each pizza, 1 pizza, is $14.78, and there is 1 pizza for 12, and there's 12 slices. All right, so we can figure out the problem. So if I know I have a total, those are all my conversion factors I need. My goal is to find out how much money. So the only thing I want left is the dollar sign. So I want to think about this problem. I want 15 people. So there's my first problem. That's my starting point. I'm going to do the railroad track version, and I had a better line this time. People. And I know there are 4 slices over 1 person. So that gets rid of people and person, same idea. I know it's not exactly the same, but we're using our brain and our noggin. We know there are 1 pizza, has 12 slices. There goes slices. Finally, coming out here, this last one, I'm saying, okay, so 1 pizza is $14.78. Again, fancy calculator, that's why we have it. It would end up being 60 times $14.78. Sorry, I typed it wrong in my calculator. Times 14.78 divided by 12. So we'd end up finding out as we work the problem, it's just going to, all those variables cancel out. So you're left with 15 times 4 times 14.78. And you have last thing you have is dollar sign all over 12. So you end up getting $73.90 for how much pizza you're going to own, how much money it would cost you to buy pizza. I want you guys to take a look at this next one on your own and see if you can figure out. I'll let you figure out, when you pause the video, figure out all the conversion factors you need first, because it's a little bit unorthodox. And then I'll then check it over mine, and then you guys can try to figure out the final conversion. Feel free to work with the person next to you. All right, so I did change locations before we finish this up, but we're going to go ahead and talk through this problem. You guys had some time to take a break and kind of think out the conversion factors. So what I want to show you guys right now are the different conversion factors that we would have used for this one. So if you're going to do this, the first thing we have to go is that it takes 47, oh, there we go, need my pen. There we go. 47 chocolate chips per person or per student. Okay, so that's our first thing to keep in mind. The second thing we have to know is that there are, so chocolate chips, sorry. We have to keep in mind that it's 29 chocolate chips for 1 cookie. Okay, then we've got to keep in mind that the teacher has 25 students. Sorry, 25. Let me clean that up just a little bit. There we go. 25 students per class, and that she has 5 classes per day. Yes, per day. And remember, the final answer she wants to know is how many cookies does she need to make her all students happy tomorrow for one day. So I'll pause the video again and have you guys take a look at, see if you guys can figure out the answer to how many chocolate chips it would take, chocolate chip cookies it would take to make her students happy. All right, so let's take a look at how we'd first set it up. So you can start really at multiple sides, but what we need is the final answer to be cookies and students, or cookies for the total of day. So we know that it takes 40, so we'll start here at that 47 chocolate chips over one student per day. So that's the idea we want, okay? So we want to go ahead and get rid of chocolate chips. So to cancel chocolate chips, we're going to have to put the 29 over one cookie here today. Okay, so there goes the chocolate chips. And then now we want to cancel out students. So we have 25 students over one class. Okay, so that lets me cancel out students. And then finally, we're going to finish out how many classes I have in a day. So I have classes, so this student teacher has 5 classes over one day. And that lets me cancel everything out that I'm left with cookies per day. And that's exactly what I want. So now I'm going to do the math. So really what it breaks down to is 47 times 25 times 5 divided by 29. So I'm going to get out my handy dandy calculator sitting over on the side of my desk, and 47 times 25 times 5, and then I'm going to divide that by 29. So this teacher, it says the answer is 202.58. Now I can't make 5/8 of a cookie, so I'm going to have to plan that I really need 203 cookies per day. That's my answer. Okay, so now that we've kind of had a chance to look at that and see how that works, so you guys got a good start on that. So let's go on and take a look at another problem. Let's take a look at another way to think about it, or a different version of dimensional analysis, maybe more having to do with unit measurement. Okay, so it's a problem. This is your third page of notes. So it's this idea of, same idea, but let's talk about, instead of just other pieces where we have, like we had our cookies or we had our pizza problem in the last one. This one is more along the lines of actual units. This is something more similar to what you might do in a chemistry class a little farther down the block. So this is our next problem we take a look at, is going, okay, now, first thing we do is find whatever is given. You can see this is in your notes. We're looking for what's given right here. And that always goes in our top left-hand square. We determine the current inversion factor, and this is where you're going to have to use some math or some general knowledge from outside to figure that out. And then again, the key to it is matching the numbers up diagonally so that we can use the quotient law to get the answer. Okay? And then we multiply it, like it says, straight across on top, and then divide by the bottom. So let's take a look at how we might do a problem like this. So we've got a couple options here. Let me go ahead and clear off my writing. How many days are in 3.4 years? So this is just like we talked about a few minutes ago. We're going to set it up at 3.4 days. And we want to get our final answer to be years. So to do that, we only really know one conversion. There are 365 days in 1 year. Oh, I wrote that problem wrong. I started it incorrectly. Sorry, I had the wrong units. That made the entire thing 3.4 years. I wrote that wrong. And now that means I'm going to have 365 days in 1 year. So now you're right, I have days right there. That's my final answer. So again, handy dandy calculator, 3.4 years times 365. That's 1,241 days in 3.5 years. Again, the goal is to use that quotient property to get rid of years. We're going to leave days, but we're going to get rid of years. Okay, and it's the same as we work through another problem. 3.7 feet. And then we're going to say, okay, how many feet? We know one conversion between feet and inches. 1 foot is 12 inches. So if I find out 3.7 inches times 12, I find out there are 44.4 inches and 3.7 feet. Okay? And you guys can see how that one works out. The last one, liters to milliliters. This is the only conversion you guys might not know, but that's what Google is for. You can always check that out, information. The ones on the test, or even in the homework, are either given to you the problem, or they're expected. I quizzed my 6th grade enrichment yesterday as I was building the test and asking them if they knew the information. So I was pretty confident if they knew it that you wouldn't have any trouble with it. So if I start with 79 milliliters, so there happens to be 1 liter, and then a milli is always 1,000. So I'm going to find out how many milliliters. 7.79 divided by 1,000 says that I have 79 thousandths of a liter in 79 milliliters. Now I'm going to have you give these next 3 a try. Let me clear my screen so you guys can see them. And have you guys give these 2 a try. Hopefully you shouldn't have any trouble with these conversions, but it'll give you a good base idea of what other units might look like. So let's take a look at what these would end up being. I'll give you a few moments if you'll pause the video, and then we can check the answers. All right, so if we start with dozens, we have 15 dozen, abbreviate, and we know there are 12 donuts per dozen, or 12 anything per dozen. So we're going to go 15 times 12. You have 180 donuts. That's enough for the entire class to have at least 1 donut, or all my 2 students to have 1 donut. My next question is similar. We start with that 39.4 inches. And then we go how many feet? So we know there are 12 inches in 1 foot. That leaves me with feet as my solution. So 39.4 divided by 12 gives me, and with this one's going to be a repeating decimal, so we'll just write it as 300.28. You can round to the nearest hundredth, just like we talked about in pretty much every other class we've done, or lesson that we've rounded. And then finally we go how many centimeters are in 15 meters. So if we start with 15 meters, 1 meter is 100 centimeters. Centi, kind of like a penny. So 15 times 100, this one I don't need my calculator for, is 1,500 centimeters. But the entire key is exactly what we're about to look back and do, that I was able to cancel out my units. Okay? Once I'm able to cancel out my units, I'm able to make sure I have the conversion factors correct. Okay? So it gives you guys a handle on what that looks like for dimensional analysis. All right, so now you've gotten a homework assignment, okay, that you guys are going to work on for the remainder of class. It's due Monday. If you have questions, I'll be back Monday, and I can meet you in help session to help you out. Have a great day.